Hello everyone, I'm Mohaminul Islam Shishir, and today I'm going to be solving this problem called trapping rainwater. So this is a hard problem from LeetCode, but the solution of the problem is kind of interesting. So in the description they're saying that given in non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So the thing is, they are going to give us an array like this one, and like each value of the array is going to represent the height of the columns in each index. So and we have to return the amount of water it can trap after it rains. So here we can see that we have 1 2 3 4 5 6 units of water, so the output is going to be 6. So yeah, this is basically what it is. Let's go to the board and try to visualize the problem. So what we are going to do is that we are going to update the pointer with the lower column height. So whichever pointer has the lower column height, we are going to update that pointer. And while after updating, so update max height if current column's height is greater than max height. So if we encounter, like for instance, we are at index number 0, and if we move to index number 1, the column height of index number 1 is 1, which is greater than the height of index number 0. So max height is going to get updated to 1. So yeah, and let's say we are at index number 1 and we go to index number 2. So at this point, max height is 1 from left side. I mean, for left pointer, max height is 1. But if we move to the next, okay, anyways, so if we move to the next index, we can see the current height is going to be current height is 0, which is less than our max height. So in this case, we will assume that we have encountered a gap where water can be trapped. So then in this scenario, if we encounter a lower column height, we are going to update the water count. So let's go through this step by step. Maybe it will get you will get a clear understanding of what we are trying to do here. So initially, left pointer is pointing at 0, right pointer is pointing at index number 11, I guess. So at this point, we are going to compare the height of both of the columns. So at this point, left has a height of 0 and right has a height of 1. So we are going to update the left pointer. So left pointer gets updated, and current max is 0 because we have encountered 0 initially. So left pointer is going to get updated. So now the current height is greater than our max height. So we are going to update the max height. So max height is going to be 1. And now we move to the next iteration. So on the next iteration, we can see that both of the pointers are pointing at columns which has a height of 1. So in this case, we are going to update the right column because the left column does not have a lower height. So yeah, if both of the heights are height of the columns are same, then we can update any of the pointers. So right column gets updated, and before updating, we will have we will have to update the max height. So max height is going to be 1, and now right column gets updated. So now the current height is 2, which is greater than max height. So max height gets updated again. Now at this point, after this iteration, so at this point the left pointer is pointing at a column of which has a height of 1, and right pointer has a height of 2. So left pointer is going to get updated. So left pointer moves to index number 2. So now the current height is 0 and max height is 1. So max height minus current height, so 1 minus 0 is 1, so we are going to update the water count to 1. Now again we are going to compare both of the heights. So left has a lower height, so left is going to get updated. So left pointer moves to index number 3, and the current height is 2, which is greater than our max height, so max height is going to get updated. Okay, now both of the columns have same height, so we are going to update the right pointer. Okay, so after the right pointer gets updated, it's going to encounter a column which has lower height than its max height. So max height is 2 and current height is 1, so 2 minus 1 is 1, so 1 plus 1, 2. Now okay, now we again compare the heights. So left has a height of 2, right has a height of 1, so right gets updated. So right moves to index number, I don't know, maybe this is 8. Okay, so now the current height is 2 and max height is 2, so we don't have to update the max height. Okay, now on the next iteration both of the heights are 2, so we can update right this time. Now the current height of right is 3, so the max height is 2, so max height is going to get updated to 3. And now left has a lower height, so left is going to get updated. So now the max height of left is 2 and current height of left is 1, so 2 minus 1 is 1, so water count is going to get updated to 2 plus 1, 3. Again left side has lower height, so left is going to get updated, and max height of left is 2, so 2 minus 0 is 2, so water count is going to be 5. Now again left has a lower height, so left is going to get updated again. So now max height of left is 2 and current height of left is 1, so 2 minus 1 is 1, so water count is going to get updated to 6. And on the next iteration left is going to get updated and the loop will end. So yeah, this is how this is the approach of the solution. Let's try to code it out. And yeah, the coding part is kind of easy for this problem. So all we have to do is have a left pointer, so left is 0, right is, let's copy this, so height dot size minus 1, so left max is going to be 0 and right max is going to be 0, and water, water is going to be 0. Now we will have a while loop here, so left less than right. Okay, now we are going to check whether which column has the lower height. So whichever has the lower height, we are going to update that. So if height of left is less than height of right, then we are going to check the max height of left. So if height of left is greater than left max, so we are going to, if height of the if current column height is greater than the left max, then we are going to update the left max. So left max is going to be height of left. Okay, else we are going to update the water count. So water plus equals left max minus height of left. And finally we're going to update the pointer, so left plus plus. Okay, and if right column has lower height, then else we're going to update the right max or the water count. So height of right, if height of right is greater than right max, then right max is going to get updated, so right max is going to be height of right. Otherwise water count is going to get updated, so right max minus height of right. And finally update the right pointer, right minus minus. And finally we are going to return the water count. So yeah, so if we submit this, this should work as okay, that didn't work because I forgot equal sign. Okay, now it should work. Okay, now we can submit this. Okay, so yeah, this was it. Like, this was the solution for trapping rainwater, which took me a long time to solve, but initially when I like saw the optimized version of the solution, it seemed pretty like easy. So we don't need to do this here. Okay, okay, so this is actually, yeah, this is the solution. So whichever column has the lower height, we're going to go to that column, and we're going to compare the current height of that column to the like pointer which has the left max. So yeah, and if the height of that column is not greater than left max, we are going to update the water count. Same goes for the right side. So if the right side column is higher than the right max, we are going to update right max. Otherwise we are going to update the water count. So yeah, this was the solution for C++. Let's do it in Python. Okay, so again we are going to have a left, a right, water, left max, right max. So left is 0, right is len of height. Okay, that didn't work. Height minus 1. Left max, water 0, left max 0, right max 0. Okay, so while left less than right, so if height of left is less than height of right, we're going to see the left max. So if height of left is greater than left max, update left max. So left max equals to height of left. Else water count is going to get updated. So plus equal left max minus height of left. And on the else part, if height of right is greater than right max. So update right max. Right max is going to be height of right. Otherwise, water count gets updated. Plus equals right max minus height of right. And lastly, we're going to return water count. Let's see if this works. It didn't for some reason. Okay, colon. Okay, also this one. Okay, now let's see. Okay, I forgot to update the left pointer here. Left plus equals 1, and also right minus equals 1. Let's format the code. Now let's update this. Yeah, so this gets accepted. Let's submit this one. Now let's do this for Ruby. Okay, so left, right, water, left max, right max, 0, height dot length minus 1, 0, 0, 0, while left less than right, and block if height of left is less than height of right. So we are going to update the left max. So height of left greater than left max. Let's just do it in a ternary operator. So height of left greater than left max. If that's the case, so update left max. So left max equals, I don't know if it's going to work like this. Let's just try it out. So left max is going to be height of left. Otherwise, okay, it's going to get a little messy like this. So anyway, so if height of left is greater than left max, so left max is going to be height of left, else water plus equals left max minus height of left. Okay, so yeah, else we have to do the same thing here. Instead of left we have right. So right, and also we have to update the left pointer plus equal 1 and update the right pointer minus equal 1. Now now let's return the water count. Okay, compile, run. Okay, this is okay, this got accepted. Now let's submit it. Okay, now we are going to do the same thing for JavaScript. So yeah, this was like my brute force solution in JavaScript. Yeah, it took me a long time to solve this problem, but eventually when I saw the optimal solution, it was like really easy. Like I felt really it felt funny. Anyways, so yeah, so we are going to have a left equals 0 and right equals height. Okay, not this, height dot length -1. Water is going to be 0, left max 0, and right max is 0, while left less than right. If height of left is less than height of right, and if height of left is greater than left max, okay, left max is going to get updated to height of left. Otherwise, no, we don't need this. Water plus equal left max minus height of left. Okay, for the else part, okay, again I forgot to update the pointer, so left plus plus. Okay, for the else part, we are going to do the same thing, but instead of left, we are going to do it for the right one, right, and right minus minus. And lastly, we are going to return the water count. So let's submit, let's run it. This got accepted. Now let's submit this. Okay, so this was the solution for trapping rainwater. It was a really interesting problem to solve. Yeah, so that was the whole video. Thank you guys for watching. Hope you guys liked it, and yeah, I'll see you on the next one. Thank you.